everyone, I'm Dr. Amanda Fetch, also known as Dr. Amanda Analytics, and after years of being immersed in data analytics, machine learning, AI, and space systems, I earned my PhD in technology, focusing on a growing global challenge of space situational awareness, or SSA. So what is SSA? SSA is our ability to detect, track, and predict the movement of objects in Earth's orbit. And so that's everything from active satellites to space debris, or space junk. So right now we have the ability to track debris in the thousands, larger than 10 centimeters. Now different sources are going to give you slightly different numbers, so I'm just going to keep it at that. And according to IADC, there's over 128 million objects between 1 millimeter and 1 centimeter in size that are too small for us to track right now, but we're going to get there eventually, which is part of the basis of my research. But anyway, these objects have the potential to damage satellites and equipment. And so we're at the point where managing space traffic isn't necessarily an option anymore, it's an urgent matter. And so we have things like this junk that can travel to speeds of up to like 17,500 miles per hour. And so things as small or something like a paint chip can puncture vital spacecraft systems. In an article through Built It Online, Rummage 2025, John Crassidis, who's a professor of mechanical and aerospace engineering, basically confirmed this figure and something that we had been looking at for years now at this point. And so why should this matter? Like, why should you care about this at all? Pretty much because all of our modern life at this point is depending on space at some point in these satellites. So your GPS, weather forecasts, financial transactions, airline navigation, even disaster response. All of those depend and rely on satellites. And so even if we have something very small, piece of debris, depending on how it's traveling, the speeds, things like this, it could trigger a service outage, national security risks, billions of dollars in damage, all of these sort of ugly things. And so right now we have tools and websites or different sites that track this stuff if you want to geek out on the topic like me. So one website, orbit.ing-now. One site that basically serves as an educational and exploratory platform that's designed to make satellite orbit data accessible and engaging for everyone. And so it provides detailed information on active Earth orbiting satellites. And it utilizes publicly available orbital element data, which also known as two-line element sets, so TLE data, to offer insights into satellite positions and movements. Pretty recently, and so when I checked it out last, and note when you check it out, it will continue to change, but when I checked it out last, basically, and you know, before I do that, let me kind of explain how to get there as well. So basically, when you get to the site, you're going to see sort of in the middle of the screen in red there, you need to click on load all satellites. And basically you're going to get this breakdown or sort of a comparison of some of the different high-level metrics you can look at of these orbital objects that's being tracked by this site. So I'll go through these kind of like one by one here. So first one, 7,180 objects in LEO, so low Earth orbit. So basically what that's telling us is these are satellites and debris orbiting relatively close to Earth, typically up to 1,200 miles high. So the region includes International Space Station and many communication satellites. Now, you have medium Earth orbit, so MEO there, 197 objects. Basically, satellites in this zone are situated between LEO and geostationary orbit. And a lot of times this is used for navigation systems like your GPS. Then you have highly elliptical orbit, so that HEO and that sort of slash graveyard number of 26 objects. So what that's basically saying is these HEO satellites have elongated orbits, and then these graveyard basically refer to decommissioned satellites moved to higher orbits to reduce collision risks. Then GEO. So geostationary orbit, 531 objects there. So basically those satellites orbit at about 22,000 miles above the equator. They match Earth's rotation, staying over the same spot, things like this. So anyway, they're ideal for weather and communication satellites. And so we have things like uncategorized or unknown, which is 4,395 objects. Those are objects that don't fit neatly into a standard orbital category, and it could be due to like irregular paths or incomplete data, stuff like this. Then orbital decay, 8 objects. These are objects gradually losing altitude due to atmospheric drag, and they're going to eventually re-enter Earth's atmosphere. Then we have the re-entry objects, which is 14 objects noted there. Those have recently re-entered Earth's atmosphere, so they've either maybe burned up or they're at the process of sort of reaching the surface. So basically, as thousands of new satellites are launched and space becomes more crowded, chances of dangerous sort of collisions, conjunctions rise. And so while yes, of course, we're looking to protect millions of dollars in equipment here, that's an issue. But what's even more crucial is for astronaut and human safety. So there's an article published a couple days ago on today's website by Collins Ashiet. And so basically on April 30th of this year, so 2025, the International Space Station performed a pre-planned debris avoidance maneuver, so they're PDAM, basically, to avoid a fragment from a Chinese Long March rocket that was launched in 2005. And so the Progress 91 cargo spacecraft fired its thrusters basically 6:10 p.m. Eastern Daylight Time for 3 minutes and 33 seconds, raising the ISS orbit to safely clear the debris, which pretty much would have otherwise passed within 0.4 miles of the station. And so that was the 41st orbit boosting burn by the ISS to avoid space junk, and took place just one day before a spacewalk by NASA astronauts Anne McClain and Nicole Ayers on May 1st, 2025. So again, take a look at that article by Ashiet that I have also. Again, all these things you'll find in the description, so you can check these things out. And another piece to that was mentioned in that article also, November 2024 incidents, ISS had performed 2 similar debris avoidance maneuvers in November of last year, 2024. So basically, this is just sort of cementing in this risk we have of orbital debris. Now, where my research started to come in here, what I did was I brought in machine learning. So I used DBSCAN clustering in particular to help organize this debris and this sort of chaos going on. And so I thought by organizing objects based on shared behavior that we could potentially better prioritize which objects are actually posing a risk, okay, before we actually do, full-on risk assessment. So again, this is a pre-processing machine learning technique. So what that can do is assist in making conjunction assessments, which are those collisions, more efficient and scalable. And so when we're finally able to track 128 million pieces of debris, instead of feeding each one into these algorithms individually for these assessments, now we can prioritize, okay, and bucket these things. So if any of this interests you, you're in the right place for my content. And so I'll be diving deep into how data science is shaping the safety and sustainability of our space environment. I'm also going to be digging into analytics, AI, machine learning, sort of in other industries as well. So in a broader context. So if this content resonates with you, please please subscribe, share anything that you find of value. And I would love for you to continue on this journey with me. With that being said, thank you for tuning in.